We can here in Tuscaloosa.
We can.
Good job.
Yeah.
I want to thank the Alabama Fire College for hosting this webinar. As Reed will tell you, we've delivered this program to just now over 8,000 first responders across the country. The program was developed by the National Volunteer Fire Council in conjunction with West Virginia University, where I'm a lead hazmat instructor. When Reed said about asking questions, there is no such thing about as a stupid question. If you've got a question, ask it, and we're going to make every effort to make sure that you go away with the information you have. Having said that, we're going to cover a lot of information tonight. This program has actually been updated twice since we did the program in January for the Alabama Fire College, simply because there's new information coming in. And as Reed will tell you, we're constantly getting new information. For example, we've added some stuff here towards the end that you're going to hear about the weight differentials of EVs and even their impact on parking garage collapses. So a lot of stuff going on. This program is developed based on the National Volunteer Fire Council's BEST model. We believe that in order to function effectively and safely on a scene, you've got to exhibit the right behavior, use the proper equipment, adhere to the standard, and make sure that you train to those standards. It's a very simple model. We use it in most of our programming, and it's a real simple acronym to remember. You can always be your best. Remember your behavior, the equipment, and the standards in your training. The objectives of tonight's program are pretty simple. We want you to be able to identify these vehicles, which is mission critical. Especially whenever you're dealing with situations of motor vehicle accidents, in adverse and inclement weather conditions. You guys have these things down in Alabama that we don't have, called hurricanes and tornadoes. In West Virginia, there's a town called Tornado, but we really don't get tornadoes up here. But these vehicles, when damaged, can pose some really difficult challenges for emergency responders. We want you to make sure that you're able to assess for real or potential EV battery damage. We're going to talk a little bit about how you're going to de-energize these vehicles, which is important because stranded energy creates all kinds of problems. We're going to talk about avoiding potential runaway and extinguishing. And I know there's all kinds of stuff out there. It's all over the board about which way to extinguish, or can you even extinguish these fires? If effectively managed and effectively handled, you can readily extinguish these vehicles. So we're going to start with, let's talk about the history of EVs. They've been around longer than internal combustion engine vehicles. The problem was they just didn't have a reliable battery source or reliable mechanism for storing energy. It's estimated that 32% of the car sales in 2030 and 45% in 2035 will be EVs. There are some manufacturers that have said they're going to switch completely over to manufacturing electric vehicles and doing away with internal combustion engines. GM actually made that statement in early 2022, but they have since retracted from that and said that they're going to be at least 50% EV manufacturing by 2035. Everybody talks about how this is new technology and, oh my God, this is all of a sudden on us, which is not true. These have been around since 1991. I got started with working with alternative fuel vehicles, we call them AFVs, in 2004 through West Virginia University, through a group that is at West Virginia University called the National Alternative Fuels Training Consortium. The group that I work with at WVU, we actually have a cutaway Prius. Took a Toyota Prius, removed 60% of the car, but it still drives and functions. But it allows you to see all the internal workings and the high voltage cables and all the other stuff. But these have been around a long time. The issues that have come about are due to the proliferation of them outside of major urban areas. These vehicles are very popular in like the DC Beltway, the New York area, urban areas where the commutes are short, they're readily accessed to charging stations. High density population areas. But now we're starting to see them in all aspects of the country, all across the country. They're pretty prolific. The next thing I want you to do before we get too far into this, I want you to change your paradigm of a vehicle. Everybody's talking about Teslas and GMs and all this other stuff, but we're going to be talking about all types of vehicles. You are probably more likely to encounter a different form of vehicle rather than a Tesla or, a hybrid Hyundai or a hybrid Chevrolet. For you, when we were at the University of Alabama in Tuscaloosa, when I was driving around, I noticed that there were all kinds of different forms of vehicles there that were alternative power. So I want you to broaden your perspective a little bit, and we'll get into a little bit more detail about that. The next thing we're going to do before we get too far into this is, what is lithium? What is it? Well, it's the lightest metal known to man. It has an atomic number of 3. So it's very low on the periodic table. You got hydrogen, helium, and then lithium. And it's highly reactive, extremely flammable. It does not react well with anything. It does not like water. It doesn't like air. It just hates everything. And if you're going to store pure lithium, you have to store it in a vacuum. So when you put it inside these batteries, it's usually combined with ferric phosphate, which is an iron phosphate type stuff. It's lithium, it's bonded with cobalt or other metals. It never occurs freely in nature. It's always in ionic compounds, stuff like salt water. In fact, the main source of lithium in many cases is sea brines, salt water, ocean water. You see all these pictures on the internet about lithium mines and all this other stuff. Well, lithium comes from all kinds of different sources.
That's correct.
How does it impact us? It impacts everything we do as first responders, because whether you're in fire, hazmat, law enforcement, EMS, towing and recovery, it's going to impact you. And I'm going to go into all those here in a little bit. It's all over the automobile and vehicle industry. There was an incident in Cortlandville, New York, where a dealership burned down because of the improper handling of a lithium battery in the service bay. There's been incidents at body shops. There's been marine incidents. Most famous one is probably the container ship that you saw that had the 900 Porsches, 600 BMWs, and about 500 Volkswagens on it, that's now at the bottom of the ocean off the Iberian Peninsula, because a fire got started in the vehicles and just they ended up running away with the ship. It's in residential applications. There's these home energy storage systems, and Reed will tell you that we're the National Volunteer Fire Council. The whole gamut has changed into the terms you're going to start hearing terms like ESS, energy storage systems, or BESS, battery energy storage systems. And it's in commercial applications, public transit, industrial, construction, telecom, retail. There was a little incident you might have heard of back in June of last year, where a 1.2 million square foot Walmart distribution center was reduced to a 1.2 million square foot parking lot due to a fire that many say was started by electric vehicles. So what kinds of types of these things are out there? Well, there's a hybrid electric vehicle, which means that it has a gasoline internal combustion engine, but it's not just gasoline now. The Prius that we converted is a propane internal combustion engine with a battery backup. Then there's plug-in hybrid, where you can actually charge the car with a plug-in range, but it's also got a regular electric vehicle thing. So you can charge, it has 2 different types of electrical system. Then there's an all-electric vehicle, or a BEV, which is just a battery. You literally, just like that's the one most people are familiar with, the Tesla, where you plug it in at night and unplug it in the day and drive it. There's a plug-in electric vehicle that I want you to think of like the electric bikes or electric scooters. The one thing I want you to remember, or one of the many things I want you to remember, is that these vehicles are designed to be charged at a specific rate over a specific amount of time to a specific capacity. So one of the things that I've been working with the FDNY, a gentleman by the name of Ron Canterman from the FDNY, we started exchanging some information, is everybody's out there now buying these chips so that they can fast charge their EV, because they don't want their electric vehicle to be sitting there for 4 to 6 hours while it charges. So they buy these fast charging chips. And what happens is you're overriding the safety protocols that are built in the computer system and into the charging system, which creates a problem. So again, EVs are more than just cars. They're bikes, motorcycles, Harley Davidson's making one. You got these scooters, you got e-bikes, you got ATVs, and it goes on. Just about anything that rolls. There you see commercial buses, forklifts. This over on the right-hand side may, and I say may have been what created the problem for Walmart. And for my friends in the agricultural industry, you were not spared. What you see there on the left-hand side of your screen is a John Deere tractor that operates at 550 kilowatt hours of energy. That whole thing, including underneath the cab, is a battery. The unique thing is on the picture on the right. Anybody grow up on a farm? Does that tractor look familiar? What if I told you, just if you're familiar with agricultural areas, that is what's called an EV conversion. They took a Ford 3000 tractor and converted it to an electric tractor. Notice the similarities? It's a Ford 3000 tractor, mid-70s model, converted to an electric tractor. And then you go on to construction sites. Fully electric backhoes. No, don't think you're just going to deal with these things on the highway. There's a lot of colleges and universities. I know you've got the University of Alabama in Tuscaloosa. You've got University of Alabama at Birmingham. You've got schools in Huntsville. Colleges and universities are having fits with these things because there's no real regulation on where you store an e-bike, where you store a scooter. And these people are taking them upstairs, putting them in the dorm rooms, putting them in their, in the backs of cars to store them, pirating power. That's the term that's been used, plug it in outside the library to charge it. Or in some cases, parking them inside like a entryway of a grocery store where you kind of have a sally port where there's one door opens and then you go in through where the shopping carts are and then go into another area and people are actually parking them in there. Well, the problem is when there's an incident and there's a thermal event, you now have blocked the exits and there's no real code on where you store a bike. And that's something that you got to take a look at. The number of and potential problems is almost too vast to enumerate. So how does it impact us? Well, with fire, of course, we've seen all the, for lack of a better term, the fire porn videos, these things burning. For law enforcement, it creates an issue with quick clearance. The National Transportation Safety Board came out several years ago and wanted quick clearance, wanted the highway cleared in 60 minutes. And law enforcement is pretty adamant with it. The troopers get on us on the interstate and everything else, want it to open up. But that may not be the case with an EV incident. With EMS, they have to treat these. If someone is exposed to the smoke or the byproducts of combustion, it is not smoke inhalation. It is a chemical exposure. And we're going to talk a little bit more about that. Towing and recovery, there are some states that require special certification in order to tow or store an EV post-accident. So it affects all of us. It affects us on the fire service on the entire continuum of everything we do, from risk assessments. And risk assessments to many is a Greek concept. They don't really understand about how to do a risk assessment. Well, for EVs, one of the simplest ways you can do is contact the local DMV and see how many EVs are registered in your zip codes that you protect. Another way is drive around, talk to body shops, talk to dealerships, see what's on their lots, take a look. Do you have SOPs and SOGs for dealing with it? Now, the National Volunteer Fire Council has a draft SOP or SOG that Reed can get out to you, and I can send it. If Reed doesn't have it, I can send it to him again. Training, that's what you're doing tonight. Code enforcement. Do your building codes address EV storage, EV charging? Who is certified to wire up a EV charging station in a residence? Where does that come in? Inspections. Do your building inspectors know what to look for? Would they recognize an EV battery system? Would they recognize an EV charging system? And I'll give you an example. A lot of places have residential building codes that require a certified electrician to wire in these charging devices. So Billy Bob goes out there and buys a brand new electric vehicle. They tell him it needs to be hooked up on a 220 circuit. So he goes out to his garage and his dryer's there along with the washer. So he hooks it up on the same circuit as the dryer, because that's a 220 circuit. Well, he's out there charging his car, and let's call it an umlaut car, because I don't want to pick on any particular brand. And Mrs. Billy Bob comes out there and she decides she wants to dry clothes. So she throws clothes in the dryer that creates a load that 220 circuit was not designed for. Well, remember what I said earlier, that these devices are designed to charge at a specific rate over a specific amount of time to a specific capacity. Well, now you've changed the load and you've increased resistance on this 220 circuit, which, as we're aware with Ohm's law, resistance creates heat. We then have a thermal event. Are you doing anything with your safety and fire prevention efforts to educate the public about EVs or lithium-ion batteries? And of course, then we have response. I apologize, got a little bit of allergies going on with all the pollen. And lastly, cause origin. You know, what started the fire? Was it the lithium-ion battery or the EV? Or was it a victim or a secondary exposure to the original start? It becomes quite difficult. And the IAAI, the International Association of Arson Investigators, has done work and put out some really good classes on how investigators can make that determination. Not all lithium-ion batteries are the same. There's lithium cobalt oxide, lithium manganese oxide, lithium iron phosphate, lithium nickel, blah, 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 blah. There's a whole ton of them. It's crazy out there. There's new technology coming out every day. And Reed and I sat on a panel working with the University of Alabama's School of Engineering that was funded by the National Science Foundation. You've got some major lithium-ion batteries. The Port of Birmingham and Mobile are just absolutely, the Port of Mobile is the third largest recipient of lithium-ion batteries in the world. So these things are coming through your town, and they're being offloaded on the ship, and they're typically in a sea can, and they're going up and down your highways. And there was an incident there in Birmingham a couple weeks ago. You know, the new batteries are going in and the waste batteries are coming out, and the way they're packaged, next thing you know, you got a problem. There's major battery manufacturers. You know, there's Cadol, there's Panasonic, BYD, LG, Bosch, Samsung, SK Innovations. There's Nutra Technologies. There's a boatload of them. And they are looking, because of government initiatives, to increase the domestic production of lithium-ion batteries. And I believe there's a large lithium-ion battery factory going in Alabama to feed the Mercedes plant and another vehicle. I believe it's Honda down there. So you're going to have these problems. I just got an email before this class that they're putting a lithium-ion battery storage facility in Long Island in the middle of a population center that's going to be a 6.5 gigawatt electric storage facility. To give you an idea, that's the equivalent of a nuclear power station in a footprint the size of a football field. That's a lot of energy. What's an EV look like? Well, there's a very simple diagram from the National Transportation Safety Board. I want you to think of, in that floor pan of the battery, there's a bunch of what I like to call supersized AA cells. They're called 18605 cells. An 18605 cell means that it's 18 millimeters in diameter and 60.5 millimeters in length. So in the floor pan of this battery, there can be as many as 7,000 of them, 12,000 of them. You get to a vehicle like that John Deere tractor you saw, there might be 60,000 of these AA batteries that are all hooked up in series. And then we're going to talk about stack design and other things like that. With a hybrid vehicle, if you look at this diagram, you see that there's an internal combustion engine towards the front. There's the regular drivetrain, but on the other end of it, there's an electric motor. They use the same transmission because simply for ease and design and manufacture. But then there's the battery pack, which can vary in size. There also may be an electric drive motor at the back. And in some cases, there's a drive motor that powers the car forward, but then there's also another drive motor that generates electricity that recharges the battery. Can be very complex. All kinds of different configurations. No two are the same. And then when you get to a battery EV, there's a battery cell in the back, usually in the floor pan, an electric drive motor, transmission, but you'll notice the orange cables. The orange cables are high voltage cables. Now, these systems have a battery backup. All EVs or hybrid EVs also have a 12-volt system, just like a regular car battery. That 12-volt system is the primer that manages the computer and everything else in the event of the high voltage battery failure. The technology, again, varies from manufacturer to manufacturer. Some have single series 12-volt batteries. Some have multi-series 12-volt batteries. Some have 12-volt batteries hooked up so that they become a 24-volt system. But you also need to know that there's a 12-volt system in addition to the high voltage system, which went maybe 100 volts, 200 volts, 400 volts, 800 volts, 1100 volts, just depending on the application. So let's take a little bit closer look at the batteries. That is what we call a battery pack. I want you to think of a skateboard. It's a platform. That same platform may be in 6 or 7 different vehicles. Now, you'll notice all the orange cables are connecting the different battery packs. At the front and the back of this battery pack that's on the screen, it's what's called a stack system. Those 9-volt batteries or 18605 cells may be stacked 3 and 4 deep, simply because they're trying to put more batteries into the occupied space so that the car can go. It increases the vehicle's range. It increases the vehicle's ability to run the air conditioner. But those thicker things are called stack systems. Here we have a different version of the whole battery system is a stack system. This is on a GMC electric Yukon. That battery pack is about 8 to 9 inches thick. There are about approximately 12,000 18605 cells in that battery pack, but you also know that it has a battery management system over here on the side. It's pretty complex, but it's designed to keep the weight of the battery centered in the vehicle. There's what a Tesla battery pack looks like. It's all encased in what we call a battery compartment. It's sealed with epoxy. You're not going to see the components of it. It has 100 kilowatt hours of energy in it. On EVs and hybrids, the energy is related to in kilowatt hours of energy. That battery weighs about 1,200 pounds. It has 6 battery subpacks in it. It's $23,000 if it goes bad. And the reason why it's sealed like that is there's no way to replace. If one cell goes bad, the battery's bad. You can't take that thing apart and just replace the bad cell. You replace the entire battery pack. Whether you agree with it or not, they're the manufacturer, and Tesla's the lead on it. Now they build some really good battery systems. Problem is, we're in the bad day business. These things are designed to work great as long as they're intact and they're not damaged. But we don't show up at people's houses at 3 o'clock in the morning because they're having a good night and getting a good night's sleep. We show up when there's a problem. Here's a commercial vehicle battery setup. Notice that there are 3 high voltage cables going into the drivetrain of this truck. This is a heavy commercial vehicle. This particular truck operates at 515 kilowatt hours of energy. There's enough energy in that battery to power the average house for about 2 months. That's running all your air conditioner, all your appliances. There are high voltage. Notice if you look just to the upper left-hand corner of the picture, you will notice those 3 cables go in, but in the what's called the drive house housing, you will notice that there is a much larger cable that's about 2 inches in diameter, high voltage cable. There's a lot of juice going through there. When you look at a Volvo bus, which is one of the most common manufacturers of EV buses out there, used in, to give you an idea, there's one city in the Northeast that has about 80 of these on the road. Your chances are your city probably has them because they're paid for through what's called the EPA's Clean Cities Initiative. You'll notice that the batteries are on the roof and that there are high voltage cables that come down in what we would consider the B post area of the passenger side and down the rear. And it has drive motors in the front and drive motors in the back. Interesting configuration. But there's a lot of battery. The other problem with this, remember that the Tesla battery weighed 1,200 pounds. These batteries weigh over a ton. So there's over 2 tons in the roof of these things. That wouldn't create any problems with extrication, would it? Wouldn't create any problems if there was an incident on the bus. Just saying. There's a very good video out of Paris, France of what happens when one of these battery cells catastrophically fail. But it's not just lithium-ion batteries. There's compressed natural gas out there, LPG. Like I said, the Toyota Prius that we have is a combination LPG hybrid vehicle. It's got a propane engine and a high-capacity lithium-ion battery. There's hydrogen powered. Now, hydrogen powered is a whole other animal, and if I'd be more than happy to give Reed the materials that we have on those. Those basically use compressed hydrogen, which is in a tank that's charged to 10,000 to 12,000 PSI that runs across phosphoric acid, runs the hydrogen across phosphoric acid and uses the ions to generate electricity. I don't want to go too far into the chemistry, but you know, hydrogen at 12,000 PSI is not a problem. If you don't believe me, just ask the people that were on the Hindenburg in 1933. So who sold the most? You know, everybody's worried about Tesla, Tesla, Tesla. I'm not here to promote any one brand. I'm not here to knock any one brand, but you will see that Chevrolet by far has the most hybrid vehicles on the road. And this is from, this is old data because no one really knows since 2020 what the sales are or how many legacy vehicles, ones that were sold in 2004, 2005 are still on the road. You got to understand electricity. These things operate at 100 volts to 200 volts, no 12 volt system, plus a 12 volt system. All electric vehicles, which are purely, they don't have the internal combustion engine, which just run off batteries, are running 400 volts to 800 volts or higher. There is new technology out there on some different things that have some vehicles running at 1200, 1400 volts. And if you remember from your basic firefighter course, there's 2 things about electricity that hurt us. Number 1 is the amount of current, and number 2 is the path through the body. And this becomes really important later on when we start talking about tactical considerations when you're responding to these things. You got to understand these batteries may comprise 18 to 30 parallel cells connected in a series to achieve the desired voltages. They're going to do what's called step up and step down voltages. And you got to understand that each battery cell, like on a hybrid, is 0.5 to 2 kilowatt hours. On plug-in batteries, it's 4 to 20 kilowatt hours. On electric vehicles, remember, it's 30 to 100 kilowatt hours, but there may be 6 of it. On each of those vehicles, there may be 6 of them. So you take the 2 kilowatt hours times 6. On the plug-in, you take the 20 kilowatt hours times it by 6. On the EV, you take the 100 kilowatt hours, multiply that times 6, depending on how many battery cells there are. So it gets really complicated. And again, there is no uniformity across all manufacturers. So what are the risks? Well, of course, we got fire, but there is a danger of high voltage shock. Not so much with the newer vehicles, but some of the older ones out there, there is a danger of high voltage shock. Now, because of the weight considerations, which we're going to talk more about later on, many of the external body components are fiberglass or carbon fiber or other things that are non-conductive for electricity, but they still have a steel subframe. And they have, you know, steel or iron, control arms and things like that. And that can be energized in an adverse incident. And I use the term adverse incidents because that could be a fire, that could be the vehicle submerged in water, that could be the vehicle off the road in a snowbank. Does it snow in Alabama? Just joking, Reed. Or it can be, some kind of
Occasionally.
can be impingement on the battery cells. And I'm going to show you a picture here in just a second of impingement on the battery cells. There is a risk of electric shock, and we're going to talk about, changing your tactics. Instead of wearing extrication gloves, you might want to wear fire gloves because of arc protection. Then there's this issue of stranded energy. That's the energy that's left in the battery after the bad stuff happens. And lastly, we're going to talk some about the toxic byproducts of combustion. So what is damage to the battery cell? Well, here's what happens when a Tesla goes 130 miles an hour sideways into a telephone pole. You have 42 inches of intrusion into the battery compartment. Now, if you look at this vehicle, they've put it up on its side to prevent ground arcing. And if you look towards the left-hand side of the picture, you will notice that they have tapped into the battery cell with wires to dissipate the energy on this battery. So it's crashes, EVs and water. Florida had fun after Hurricane Ian with EVs catching on fire spontaneously, or simply issues of poor maintenance. Someone, alters you can buy what they're called PROM chips, performance reorganization, something optimizing, something chips. I don't remember the exact name for it, but it's called a PROM chip, PROM. And what that does, that car is not designed for it. There is actually an EV racing league out there, just like NASCAR. It is really taken off in Southern California and up in the Beltway area around DC. Just crazy. So they're modifying these vehicles and they're having all kinds of problems. So we do from there. So now you understand a little bit about the picture. So you got to do a risk assessment. You got to figure out where you're going to be exposed to this. You can take a look at call data. FDNY has done amazing things. You can look at their bulletins. They're going to have Yes.
Mike Bailey with Brookwood said, can temperature also affect any of these batteries? Like
yes,
being too hot or too cold?
Excellent question. Under lithium iron phosphate, lithium cobalt oxide batteries, cold temperatures create all kinds of problems with charging. They create like temperatures usually below 20 degrees Fahrenheit, or high temperatures above 110, 120 degrees Fahrenheit, create huge problems with these batteries. They have an operational parameter on some of them, what's called 0 degrees centigrade to 40 or 60 degrees centigrade. But that's an excellent question. Yes, especially the older electric vehicles are extremely temperature sensitive. Good question. Going back over here, you want to take a look at call data. You want to do an area assessment. You want to develop SOPs and SOGs. Again, the NVFC has a sample SOP and SOG that we can let you use. You want to develop a training program. We're actually working, we're going to work on, we'll tell you that we're working on doing a train the trainer down there and train instructors for Alabama to do the operations level class. Here in West Virginia, we've been working with our Department of Environmental Protection. I'm doing a class here, I think weekend after next, where we're actually going to burn some EVs and do an extrication class. I will tell you, make sure you get permits, because we'll talk a little bit about what happens when you burn these things. You want to work with other key stakeholders, tow operators, law enforcement, make sure that you got a plan. And you want to look at your resources. Every EV and HEV out there has an emergency response guide, and you can get it online. Now, the issue is they're not all organized the same. It's not like a safety data sheet that you get from a chemical. The information's all over the place. They put some of them, in my opinion, this is just Tom Miller's opinion, it and $7 will get you a coffee at Starbucks. In some of them, they put all kinds of sales stuff and how great their vehicle is in the first 10 pages before you get into the actual safety information. I'm working on an international panel. Reed will tell you that we're trying to bring some kind of sense to the madness and come up with universal emergency response guides for all systems that will all be organized in the same manner. But there's a lot of resistance from some manufacturers. They don't want people saying, oh, this car may not be safe under these conditions. Interesting. They say, oh, that'll scare the consumer away. Well, I think the consumer has a right to be informed. So your initial response objectives, when you roll up on scene, first off, you got to identify this thing. Second, you got to immobilize it. And third, you got to do the proper disableization. You got to get rid of that energy. And sometimes it's not so easy. So how are you going to identify it? Well, sometimes there's badging, and it'll say hybrid, eco, EV, PHEV, Ford Lightning, anything that has a Ford emblem on it that says Lightning, it's an EV. Certain models of vehicles like Prius, all Priuses are either all electric vehicles or hybrid. All Toyota Sienna vans are hybrid. All, Chevy Volts and Chevy Bolts are EVs. Sometimes it's just the model. You may want to look at, if you guys are like me, I used to roll out on the interstate. The fire department I was on covered 20 plus miles of interstate, and you could either recognize the car or there was a wadded up piece of metal in the median that you had no idea whether it started out as a truck, a car, or whatever. It was just rolled up metal. So you have to go around and look and see, are there charging ports? A lot of the manufacturers put the charging ports where the fuel filler was. For example, on the new Ford Mustang EV, it's up on the front fender. It's not back where the fuel cell is. If you see what looks like a fuel door on the front fender or on the in front of the windshield, probably it's a charging port. The next thing to look for are exposed bright orange or neon blue cables, or other brightly colored cables. It started out that the National Highway Transportation Safety Administration said all high voltage cables were going to be bright orange. Medium voltage cables are neon blue. Well, some manufacturers decided we're going to be a little bit different, and so we're going to make them hot pink. And everybody went, what? Well, there is no regulation. There's no standard. They can make them whatever color they want. There's nothing that says they have to put them this way. I can't stress that enough. There is no standard on badging. Certain manufacturers push back and said, so you're going to tell me how to label my car? Nope, ain't happening. There's also no standard on where the high voltage cables have to be located. They could be on the firewall. They can be up the center of the floor pan. They can be down the rocker panel. They can go up into the roof area, come back down the A-post, and go into the engine compartment. There's nothing. None at all. There's no federal government standards on battery locations or voltages. If you go buy a new Lexus EV that's built on the RAV4 platform, I think it's the ES320 or EV320, there's no spare tire because they put the battery where the spare tire is, and the vehicle runs on Michelin run flats. It doesn't even come with a spare tire. It looks like a spare tire cell, but it's not. That's a battery in there. Then there's emergency response guides, but none of the ERGs are organized the same across the board. It's all over the place. So because of that, some areas, you get up around the Beltway, again, around Washington, D.C., Loudoun County, Arlington County, places like that, they assume that every vehicle they run into is an electric vehicle until they find out otherwise. And they implement the response protocols. It works for them because there are so many of them. You have to decide what you're going to do. We can provide you some guidance, some coaching on your SOPs and SOGs, but eventually you all have to make the determination. So once you identify that it's an EV, you got to identify is there potential battery damage. This particular battery cell is a battery that came out of a EV. The car crashed into a road, crashed on a road into a telephone pole. The car went one way, the battery went another place. So the car's on fire, the battery's on fire. So now their one vehicle fire turns into two. So you want to look at, is there any obvious damage to the battery cell area? There's an incident out of Mecklenburg County, North Carolina, which is the Charlotte area. Car driving down the road, woman hits a deer in the road, drives down the road. 10 minutes later, her car's on fire. when they actually looked at the vehicle, what caused it, it was the deer hoof or antlers went up into the battery cell and damaged the battery. And that was sufficient enough to, catch the car on fire. You want to look at impalement into the battery cells. You want to look at major body kinking. And I'm talking about is the car kinked at the roof line, at the rocker panel, at the A post or B post. If the body's kinked, you got a problem. That's why these vehicles have to be towed on a flatbed. You can't pick them up with a wheel lift wrecker because you result in kinking the body. Are there fluids leaking from an EV? For example, the fluid is many of these battery cells are cooled with ethylene glycol, propylene glycol, an emulsificant gel, or something else. Because these batteries are designed to operate when the car is running and moving down the road, they generate heat. They may be operating at 130 to 170 degrees Fahrenheit. Well, so they have a coolant in there. Well, if you see antifreeze leaking from the rear wheel or underneath the B post, that's not normal. And that probably tells you you've got damage to the battery. And a lot of the antifreezes that are used are bright purple, bright pink, almost orange. So you want to pay attention to that. Are there wisps? Yeah.
Tom, real quick question, two parts here. They're asking how thick is the insulation on the high voltage cable and thickness of the, and of course, I'm sure that's going to be manufacturer specific, and the thickness of the battery compartment itself. And likewise, I'm sure those are going to be manufacturer specific as well.
The insulation on the high voltage cable is typically about 2 millimeters thick. It's usually some kind of braided, it's not metal, but it's like a braided orange fabric. I want you to think it's like a fire hose covering over top of it. It's usually about 2.5 millimeters thick. As for the thickness of the battery, it can go from flat out, 80 millimeters, which is the 60.5 millimeters plus, 10 millimeters on each side for padding or insulation, to a stack system where the battery compartment may be a foot thick, especially like on an SUV. There's parts of the Hummer on the GM, the new electric Hummer, where the battery cell is almost 21 inches thick. So, it's a big brick. In this particular case, this battery comes off a Tesla, and the battery is about a little over 5 inches thick. Just think of like your cell phone battery on steroids. It's about 5 inches thick, about 5.5 feet long, about a little over 42 inches wide. And it's full of these kind of cells. They look like AA cells. That's what's inside of it. And that's what they look like when they explode or vent. There's a thermal event. And I apologize. When I'm sharing my screen, I can't see the chat. So I appreciate Reed monitoring the chat. I want you to ask questions. Reed will tell you I'll be here as long as it takes to answer your questions. We do not want you to go away this evening saying, I wish you would have answered this, or I had a question, but I didn't answer it. The Alabama Fire College has really been a great partner to work with, and we want to make sure that you have the information you need. But that's what the cells look like. They're like AA cells, and you can see where the ends are burned out of them. That's because they explode. And I've argued the definition, because I've had people from manufacturers tell me our batteries don't explode. Well, in my experience with EOD, Reed will tell you I've played a little bit of stuff with stuff that goes boom. With NASA and other places. An explosion is an uncontrolled event that results in the discharge of heat, pressure, and a potential for fragmentation or deflagration. These things will fly. To me, that's an explosion. Now, are we talking about speeds per minute or anything else? I can show you when we get here. I can show you that when we did test burns on a battery cell that we built that was 1/300th of an electric car, we had these individual 18605 batteries coming out at about 540 feet per second, and they would fly about 100 feet. To give you an idea, a bow and arrow an arrow coming off a bow shoots at about 330 feet per second, but we have batteries coming out at 540 feet per second. So you make your own determination. To me, I operate under the keep it simple, stupid method. If you show the video or have someone personally observe it, they're going to call it an explosion.
Tom,
So
you have that video later on in the presentation, don't you?
I have a couple videos.
Excellent.
I will show you.
That's a great video, folks. I think that will bring this home to you in ways that words cannot.
So you want to take a look at, chalk and block the wheels. If you're going to immobilize, don't use your metal wheel chocks, because what you may be doing is creating a ground. Your aluminum, everybody says, we'll get the aluminum wheel chock off the fire truck. Not so good idea. Use a wood cribbing block, use a composite cribbing block, and chalk the wheels. Set the parking brake. In the operations level class that we do, we teach you how to do it with a pike pole. You reach inside the compartment, set the parking brake, push the ignition thing to turn it off, grab the keys, and do all kinds of things. Put it in park, etc. You do not want to lean in there, because these thermal events or adverse incidents can occur in 2.5 seconds or less. It goes from perfectly normal to a really bad day very quickly, and you don't want to be leaning over this. So you want to be careful. Going on a little bit more to disabling, make sure you push the ignition off. Again, do that with a pike pole, and get the key fobs away from the car. Incident out of California. Lady crashes her car into a guardrail. It was a GM model. Two firemen show up from Cal Fire. They're in the car treating, and one guy's holding C-spine. The other guy's working with a patient. Well, the woman's daughter had called trying to get a hold of her mom, and of course she couldn't raise her. So she calls OnStar, and OnStar says, hey, we can thing, and we'll check the car. So they push a button, and the car starts up and drives over the hill with the two firemen and the patient inside of it. These cars have a remote start capability, which is bad, very bad. 10 minutes to Wapner bad. Get that key fob 16 to 25 feet away. Fire departments that I've worked with, and Reed will tell you, I've gone all over the country. I've got some of them putting it in a bucket and putting it in the cab of the fire truck and literally taking it away. But that may not be enough. If the victims are standing outside the car, ask them, can you start the car with your phone or your Apple Watch? If you can, turn it off. You don't want them out there playing, saying, well, how bad's my car doing? I want to try and start it. Because some of these cars, these electric vehicles, they pair with the phone. And if you own one, you know what I'm talking about. They'll pair with the phone, and they'll give you a diagnostic report. Well, once you're pairing with it, you're powering it up. And that's bad for fire departments. I fought a lot of vehicle fires in my days, 38 years in a fire service. I don't like to chase the car up the road, especially if the victims are still in it. That's just not a good day. There are disconnect systems. You want to disconnect the 12-volt battery system first, because that runs the brain for the car. Now, remember, cars are mechanical devices, and I don't care how much engineering you put into them. And there's a lot of technology goes into them. They are a mechanical device, and any mechanical device is subject to failure. That's why I never wanted to be an astronaut. I never wanted to climb on top of $1 billion firecracker where every part was built by the lowest bidder. Loved watching, The Right Stuff, great movie, but I don't want to climb onto a bomb. It may be an atypical battery connection, like those of you that have been around farms again, maybe a battery disconnect. Maybe a battery disconnect looks like your fire truck. Maybe a pull switch. Maybe a e-stop button, for lack of a better term. But it may be also just regular battery cables on a 12-volt battery that you got to take off to disconnect that 12-volt system. On some vehicles, there are cut points, and they are clearly labeled. Little fire hat with a cut. Well, you cut on each side of that yellow tape, each side, because you want to take out that 1.5 inch to 2 inch gap, because you want to eliminate the potential for arcing. This particular model here is a BMW, has cut marks, but it's not high voltage cable. What you're cutting is the 12-volt system here, okay? Here's another picture of a cut line here. If you notice the picture on the right, that is a blue cable. So there's a cut on the medium voltage, but notice it's not on the high voltage cable that's below it. There's also a fire department warning sticker that you can see there at the bottom that says, hey, here's where the other place is you need to disconnect. These are not always readily available. They may be hidden behind a compartment in a trunk. They may be right under the hood, clearly labeled. They may be in the kick panels underneath the dash. Again, no commonality where they're at. The newer model Teslas have what we call the ripcord thing. It's got a loop that you pull and it disconnects the battery. Pretty simple. I like the technology. It's a progressive safety step. Makes it easy. Here's where you're going to get some blowback. I've pulled a couple of these on incidents. One had one that rear-ended a milk truck. It was rather interesting. But you pull one of these and they've got to take the car back to the dealer. It's not simply like you can plug it back in once you've pulled it. Once you've pulled it and it's done, it's got to go back to the dealer. And in this case, they were charging the person $1,800 to put the cap back in. Well, not my fault. I had to neutralize the vehicle. For the high voltage cables, there's all kinds of ways to disconnect the power. There's over there on the left, we have a cam lock system, 2 cables, positive, negative cam lock. And we teach you how to, in the operations level class, we teach you how to use these with a pike pole. You just simply pull the cam, pull it, and it disconnects. Center one is a different form of cam lock. On the right-hand side, it's a 2-prong high voltage connection. But like Billy Mays says, wait, there's more. There's a right angle pull and clip. There's a 5-prong on medium voltage, but there's also a 7-prong, 9-prong, 12-prong, depending on the battery configuration. There's a right angle cam lock that has a connection on it. Again, all kinds of differences. On the blue center cable here, it's a twist lock, kind of like a Storz quarter turn, twist and disconnect. They may be on the firewall. There's a cam lock that you just pull, you got to slide it to the left. It pulls out and it pulls out. Over on the right-hand side there is a battery disconnect. It's it's called a pull plug. It is hidden behind a panel in the trunk. Again, no uniformity, no consistency. You got to know manufacturers. So you may be out there, if you have connectivity, downloading the ERG to find out where the disconnects are. There are hundreds of different places. Color-coded are on hybrid and EVs are usually orange. That means they're high voltage, which is 400 volts or higher. Medium voltage is blue. You don't ever, never, ever, never, ever, ever, never cut the high voltage cable. Don't do it. Just bad stuff will happen. You run a risk of arcing. You run a risk of getting electrocuted. It's not a good thing to do. Look for where they unplug. Same with blue, medium voltage. Again, these are mechanical systems. You got to be very careful. Just because you don't hear engine noise does not mean the car is off. The Prius that we have, I can drive around, it's totally silent. I've driven it in parades. It runs completely silent. In fact, even when the propane engine's running, it's pretty quiet. Until you isolate the key fobs and disable the 12-volt system, silent movement or instant restart exists. This car can start up without you. And a lot of them run a self-diagnostic, and they're, kind of like from Star Trek, we run a diagnostic. Now let's fire ourselves back up and see what's working and what's not working. It's just a bad situation. Again, never, ever, ever cut the things. Just bad. There's a new technology out there called the plug, and it's being marketed all over the place, and people say it's a great thing. And I've used it. It works really well. If you watch all the test videos, it's used on a vehicle that's sitting on a parking lot that has not been damaged. You put it in there, the car won't start, car won't move, works just fine. I'm sure it's a great tool. Couple issues. One plug does not fit all vehicles. You got to buy a couple different plugs to make sure that you got the, the 3-prong, the 4-prong, the Tesla model, the American model, the domestic model. You got to make sure that you get multiple plugs. Great thing. Works in theory. When you plug it in and it's working, the bright green light comes on. Again, there's charging ports for fast charging. So you got to make sure you have the right plug. Those are the 3 main ones. There is a little problem because when you read the fine print, because I'm one of those fine print people, I like to read, you could get run over plugging this thing in. If the car has been damaged and malfunctions, it may not work. You may actually trigger the reaction that you didn't want to happen by plugging it in. And that can be a bad thing. So you have to evaluate it. I would strongly encourage you. It's a great tool, but if you're going to use it and deploy it, I would make sure that you get some people in there and get to test it and make sure that you test it under adverse conditions. Go to a local salvage yard, go to a wrecker yard, and see if it works on damaged vehicles. Because every video I've seen about it, it's working on normal vehicles, which is just bad. So we're not going to do a test. Reed said you don't have to take a test. Everybody give Reed a hand. Let's talk about vehicle fires. They account for about 16% of the reported fires.
Hey, Tom, I do have a couple of questions before you get into the fire part.
Sure.
This is one that I never thought of. This is a good question. Is there a lightning consideration for electric vehicles? Does it create a fire risk, or are they grounded well enough to prevent an overload on the battery or whatever other risk it can create by being struck by lightning?
That's an excellent question. And that is a question has been asked before. You have to realize that anything that has high voltage flowing through it attracts lightning. And as we all know, lightning doesn't come from the sky down. It goes from the ground up. So depending on your humidity and the dryness of the air, that current flowing through the charge, let's say you have your EV out in the yard and you've got a 30-foot pigtail charge charging it. So you got 220 volts going across the ground into this EV sitting out in the driveway. And you've got a whole bunch of rebar in your driveway. Yes, there are documented incidents of your EV attracting lightning or generating a lightning discharge. Inside a house, not so much. I know of at least 2 incidents that have occurred. One occurred in Texas, one occurred in South Carolina, where the vehicle was the target of a lightning strike. And in the South Carolina case, I know it triggered a fire. In the Texas case, it just simply blew the car apart. But that's an excellent question.
And I have one more question. He states, I think this is from Brookwood, you may be coming to this later with these batteries. Is acid a concern, or are lithium batteries different in that aspect? I know he works at a plant there. It says, I know when we have a battery spill in the plant, we must have acid neutralizer to clean it up.
Yes. Depending on the manufacturer of the battery, there's phosphoric acid. We're going to talk about that a little bit. There's hydrochloric acid in some of them. There is typical sulfuric acid, like you have in a regular wet cell battery. The amounts and quantities differ greatly. In the hydrogen vehicle that uses a hydrogen tank and the electrical discharge, there's phosphoric acid, a pretty decent amount of it. The question becomes what are your reportable quantities in your state? So when you go to, fight a vehicle fire, are you going to monitor, do you have the extra personnel? Do you have acid detectors? Are you going to carry, 100 pounds of sodium bicarbonate or another base to neutralize the acid? There's a lot of questions. Everything we've done in the testing, and Reed, the testing that we've done, the solution to pollution is dilution. Copious amounts of water. That's why a lot of the manufacturers, their ERGs say to apply 3,000 to 8,000 gallons of water if you have an incident with these. That's a lot of water. That's a lot of high quality H2O. But it is a concern. Where we're seeing it to become more of a concern is events or incidents inside parking garages or tunnels. It's a big concern there. especially, you guys probably in Huntsville deal with this. I figure Birmingham deals with it, where you have multi-story parking garages underground. The question that just popped up there from Ryan about heavy rain. Tesla just finally issued a warning today about don't drive your Tesla through high water. They do not react well. Once water gets inside the battery, you're going to start having what's called uneven or sporadic discharge of the cells, and you're going to end up with a thermal event. They are not designed to go through water. And some, different manufacturers have different levels of moisture protection. Most of the battery compartments and battery cells are completely sealed to prevent moisture from entering into the battery. Brings up a good point. Any neutralization of an acid, it is an exothermic reaction. It generates heat and energy, but it's not enough heat to necessarily compound your problem. You're going to get maybe 20, 25 kilowatts, not kilowatt hours, but 20, 25 kilowatts of energy coming off that exothermic reaction. It's not really enough to generate heat, enough heat to create a big problem or spark a secondary incident. I can tell you that you're already going to be dealing with heat. And whenever we get into talking about these, when a lithium battery decomposes through fire, you can have temperatures of 1700 to 2200 degrees. So putting a base on the acid is not going to come anywhere close to those temperatures. Did I answer your question, Ronnie?
Ron asked another question there about, I think it's the last one that's in the chat. If you see that, I think you're killing a bunch of questions off about the flooding by answering those.
Yeah, flooding. Yes, there is a potential for the stranded energy to energize the vehicle. There's a lot of stuff in there that says don't touch them when they're submerged in water, bring them out, let them drain for at least, leave them alone for 24 hours. Now the question is, how do you hook onto the thing? There you go. Wear good thick fire gloves. Make sure that your wrecker operators, your tow operators are using welding gloves, or loan them a pair of fire gloves, because it's going to decrease the arc protection. Try and minimize your contact. I've seen wreckers that have modified J hooks, where the J hook is 3 feet long, so that they don't have to, kneel down right in front of the car and stick their hand up underneath the car. There's a lot of issues, and you gotta figure out what operates safely. One wrecker service I know has made their own J hooks out of bending rebar, and it's the salvage hook. I'm going to talk about what if victims are trapped under special situations. Trust me, I'm going to get to that one.
And you see the one from Lacey Springs there.
Yeah, about the dual battery EV setup. You're not going to know unless you can put some kind of amp meter or something on that. You're not going to know if both batteries are discharged. And almost all batteries, you got to keep in mind, when you run your EV, it's designed to go down to 20% charge and then show that the battery is dead. But that 20% charge is stranded energy. And that 20% charge is enough to create a problem.
And I think you cover the question about foam in the firefighting section. So
we sure do.
We'll let that one ride through there. So I'll back out of the way, Tom, and get you back in the driver's seat.
Sure. Great questions, guys. Great questions, guys. And that's what I like. It's a good, ask questions and we'll provide you as much answers as we can. In looking at vehicle fires, hybrid vehicles have the highest rate of fires per 100,000 vehicles sold. Just the way they are. That's according to the National Transportation Safety Board. So how do car fires start? Well, number one cause is collisions with other vehicles. Again, we're in the bad day business. We don't get called because there's 300 cars on the parking lot at Walmart and every one of them's just fine. We don't know about that. But heaven forbid someone slam into 300 of those cars, or like was on the industry things here, 3 Ford Lightning pickup trucks catch on fire on a dealership lot, or like I posted one today about a Tesla that spontaneously combusted on a new car lot. We're going to find out about them. Poor maintenance. Again, with EVs, it's mostly unauthorized modification maintenance. There's electrical failures. Again, these are mechanical devices that are subject to failure. Down at the bottom, these are all in blue because they really don't apply too much other than the one vehicle battery damage. You know, but interestingly enough, arson, I'm going to change the color on arson in the next series that I do on this modification, because the National Association of Automobile Adjusters is showing that there's getting to be a higher degree of what are called suspicious electrical vehicle fires. And I'll give you an example. Guy goes out there and spends $115,000 for an EV truck. And when it's sold, they told him, hey, you can go 250, 300 miles pulling your camper. Well, he gets that truck out there and it only goes 70 miles on a charge. He takes it back to the dealer 3 or 4 times. They tell him, hey, look, you know, the second you drove it off the lot, your $115,000 truck's worth 50 grand. You're 65 grand in the hole. Well, okay. So the guy gets it in his mind, well, there's all this stuff out there about EV fires. I've Googled it, everything else. I'm going to sell it to the insurance company and get out from underneath this thing. There's actually, you can Google this, there are insurance companies that are getting very hesitant about insuring some of these vehicles. Give you another example. Rivian made electric trucks. Rivian has since gone out of business. Where am I going to get my truck fixed? Can't take it to the Ford dealership. Can't take it somewhere else because there's an issue with parts. You know, I read somewhere that there was one part that if it went bad was pretty common going bad. You can't drive the truck. It's a $300 part, but once it's bad, you can't drive the truck. So what do? I'm making payments on a thing sitting out in the parking lot that's a paperweight. It's interesting times, folks. So vehicle fire data, again, hybrids are the most common per 100,000. As you can see, they're like, you know, 2 times that of gasoline vehicles. But when you get down to battery EVs, it's really low. Now, I've seen arguments about the statistic. This is vehicle fire only. This isn't vehicle fire as a result of wrecks. This is the vehicle burned. And some people have said that's skewing the data. Well, especially considering, you know, that slide there that says the #1 cause of fires is collisions. But there's this push to make sure the data looks, I don't know who's doing the push, but to make sure the data looks like these things are really safe. Statistically, you know, there's an old saying, statistics lie and liars use statistics. That's why we want you to look at your call data. Now I'm going to show you a video from the National Transportation Safety Board that talks about the dangers and the information that we face with regard to electric vehicles. It's about a 10-minute video.
Jennifer Homendy, and I'm a board member at the National Transportation Safety Board. Did you know that fire departments across the United States respond to about 170,000 vehicle fires every year? Most of these fires are in passenger cars. Firefighters and other emergency responders are used to dealing with fires in gasoline-powered cars. But a fire involving a high-voltage lithium-ion battery in an electric car can be challenging.
Hello, I'm Tom Barth. Over the last few years, I've investigated battery fires in electric cars. The NTSB published a report describing the investigations that I worked on and the safety risks battery fires in electric vehicles create for emergency responders. Let me give you a few highlights of the fires we investigated. In August of 2017, an electric car crashed into a house and burned in Lake Forest, California. Firefighters had trouble extinguishing the fire. They poured thousands of gallons of water onto the roof of the car. They didn't realize that they had to direct water onto the battery compartment under the car to cool the battery and stop the reaction causing the fire. This is called thermal runaway. Another challenge in Lake Forest was that the battery reignited while responders were winching the car onto the tow truck. New short circuits were created when the battery
We're working
shifted,
on the volume issue, folks.
causing the fire to restart. The battery reignited once again at the tow yard. A crash in Mountain View, California created a risky situation, managing a high voltage battery fire on a busy freeway. It was a challenge for emergency responders to know when and how to safely move the car. And then, 5 days after the crash, the car's battery reignited at the tow yard. Firefighters were called to extinguish the fire. Even after the fire was out, the battery retained energy and was at risk of reigniting again. The manufacturer's engineers tried, but failed to remove the energy that was left in the damaged battery. This is called stranded energy. In Fort Lauderdale, Florida, a high voltage lithium-ion battery burst into flames after a car traveling well over 100 miles per hour crashed into a wall. While the wreckage was being removed from the crash scene, the battery separated from the car and reignited on the tow truck. At the tow yard, investigators confirmed the presence of high voltage and stranded energy in the damaged battery. A car fire in West Hollywood, California shows us that a crash is not the only event that can cause the high voltage battery in an electric vehicle to catch fire. Here, an internal battery failure led to the fire. Firefighters quickly put out the flames, but they called the automaker for advice on how to stop the car from smoking. Firefighters were told to apply water to cool the battery, but where to apply the water was not clear. Guidance specific to each electric vehicle model is vital for emergency responders, regardless of what causes a high voltage battery fire.
These fires illustrate what we all know, that severe crashes or component failures create safety risks in any form, gas, electric, or hybrid. The NTSB identified two main safety issues in our report. First, while the emergency response guides from electric car manufacturers are adequate in some respects, they're lacking in others. For example, they contain almost no information about how to handle stranded energy. Second, federal safety standards don't address high-speed, high-severity crashes involving cars powered by lithium-ion batteries. Thermal runaway, battery reignition, and stranded energy are key safety risks in electric car fires. The NTSB's report details actions that the National Highway Traffic Safety Administration, automakers, and fire and tow associations must take to protect our emergency responders. You can find the report on our website at ntsb.gov.
I apologize for the volume with that. I had it maxed out on mine, so do apologize. Gotta love technology. Let's talk about shifting a little bit to the EMS side of it. The lithium ion batteries, these generate really high heat. Talking about 1700 to 2200, 2500 degrees. When these things burn, they give off large amounts of hydrogen fluoride, HF. And you got to understand HF's toxicity. It has a permissible exposure limit of like 4 parts per million. And to give you an idea, hydrogen cyanide can have a PEL of 44 parts per million. So this stuff's like 10 times more dangerous. They also give off phosphoryl fluoride, which goes back to if someone is overcome or encounters the smoke from these, one of these incidents, you can't treat it as smoke inhalation. You've got to treat it as a chemical exposure. And you've always got to deal with these incidents wearing full PPE, including SCBA. And now the questions will come. So you're telling me I get off the, truck on an automobile accident with entrapment. So now I got to don an SCBA. If you know an EV is involved, yes, don an SCBA. Full bunker gear, fire gloves, and a positive pressure SCBA. Approach from uphill and upwind. Treat it just like you're dealing with, any other chemical. Then you get the situation of thermal runaway. It's where there's an uncontrolled reaction in the battery packs. And, you know, people say, well, how do I monitor that? How do I check with that? Well, you get the thermal imaging camera. So now I'm telling you, when you roll off on one of these incidents, you get out of the truck, you're now in full bunker gear with an SCBA, and now you got to get the tick for an auto accident. Yes, because you can actually scan across you pan across, make sure you're looking at the batteries, not at the car, because just like the outer skin on the car and the roof of the car, it doesn't know the difference between rainwater and fire water coming out of your fire hose. You got to get the thermal imaging camera on the batteries underneath the car. And like I said, these things operate at 130 to 170 degrees. If you're seeing temperatures on the battery compartment of 250, 400 degrees, you've got a problem. And this thermal runaway can result in the ejection of gas, shrapnel, particulates, extremely high temperatures, smoke, and fire. Just bad. So what causes thermal runaway? It's an internal short in the battery. It's something breaking down in the mechanical process. The cathode or anode electrodes get physically separated through a damage from a crash. There can be all kinds of different things. There can be defects in the cell. There can be moisture inside the battery. It can be caused by an overcharging of the battery or an undercharging of the battery. Multiple over discharges, in other words, where they took the battery below the 20%. An external short circuit, they wired it up wrong. High and low temperature environments, as we go back to the question earlier, including fire or extreme cold, 30 degrees below zero, probably might have a problem. Lots of different issues. To avoid it, the first thing you have to do is de-energize the vehicle. Now, there's different things depending on different manufacturers. Our operational level class, we talk about, grounding the car, driving a grounding rod in the car into the ground, hooking a cable up and dissipating that energy into the ground. The second thing is you have to cool, but you have to cool the batteries, not the car. You actually got to get the water on the batteries. And every ERG for passenger vehicles says between 3,000 and 8,000 gallons per car. Then sadly, you got to monitor it. Continuously monitor this thing for 30 minutes, maybe an hour after the incident to make sure that, there's not going to be a problem. Is it the same with every vehicle? No. But there's some standard things you can do for strategies and tactics. Make sure you always approach uphill and upwind. Always make sure you wear full PPE, including positive pressure SCBA. If there's a fire or you're going to cool the batteries, you got to get to the batteries. Again, spraying water on the hood of the car, the doors, or the roof, or the glass. They don't know the difference between water coming out of your fire hose and rainwater. You got to get it on the batteries, and you got to monitor for indicators. Run that thermal imaging camera over it. Make sure you're cooling the batteries. Make sure that you're seeing temperature differentials. Every time you hit it with water, you do a pan on it, you should notice temperature drops of between 60 and 150 degrees. That will tell you if you're getting effective. Now you have to realize on that battery that's 5 feet long, 42 inches wide, 6 inches deep, when you hit it with the thermal imaging camera, the area where the thermal runaway is going on maybe only be the size of a baseball. The rest of the battery's cool, but that size of a baseball is what you got to cool, because it can spread, and it can eventually spread to the entire battery. Delray Beach, Florida, this is an incident. They had a fire from this August of 2022. You'll notice that they flipped the car on its side to access the batteries. That was their strategy and tactic. They got a car on fire in the middle of the interstate. Okay, we're going to flip it on its side and spray water on it. Got to give the guys credit for creativity. It is what it is. And there's studies out there now that are showing that if there's any incident involving the batteries on an EV, insurance companies are totaling them. Because they just can't take the risk of putting it back on the road. So flipping it on its side, don't worry about damage. The next incident out of Stamford, Connecticut involved a bus. And unfortunately, it resulted in a firefighter being injured. Pretty seriously injured. They ended up putting over 22,500 gallons of water on this electric bus, and the fire sent 2 maintenance workers and a firefighter to the hospital. I have the article. The firefighter is now functioning at 30% lung capacity. He's permanently disabled because he breathed in the smoke. He was treated for smoke inhalation and not a chemical exposure. And, you know, a lot of EMS, their protocol for smoke exposure is high flow O2, 2 large bore IVs, keep, you know, TKO to keep it open. Well, the problem is with hydrogen fluoride and phosphoryl fluoride, all you're doing is increasing the permeation rate of that toxin into the blood system, causing permanent damage. You're only making things worse with high flow O2. So you got to treat it as a chemical exposure and make sure that your local medical command has a protocol in place. Again, battery cells after fires, that's what they look like. It can be, you know, a complete conflagration. In suppressing these fires, you better be prepared to deliver water. Now, on controlled access highways like interstates and other places, where are you going to get 3,000, 8,000 gallons of water? You're going to set up a tanker shuttle. Does your fire department have access to tankers? I worked with some folks from municipalities, and one large municipality is using their aerial trucks to act as standpipe systems to get water up to bridges. Pretty creative. Ladder truck hooks up to a hydrant down on the street level, runs the stick up, you know, and they connect fire hoses and their water supply to the engine off the improvised standpipe system. Don't ever, never, ever try and attempt to pierce the engine or battery compartment with a piercing nozzle. That's just not good. You may complete the ground and find it out to be a shocking experience. Following the extinguishment, make sure you use a thermal imaging camera to determine the temperature fluctuation. Again, these temperatures can go up and go down. Different things. I'm going to go over a couple different tactics that you can use to expose the battery. Being from West Virginia, I like to keep it simple, stupid. And this one is called the one side tilt lift. Basically, you use a ladder and some crib blocks, use the ladder like a lever, pick the car up so you can expose the batteries. Pretty simple. A lot of engine companies may not carry rescue tools. This is a simple way to do it. Once you get the car 18 to 24 inches off the ground, in this case, you crib it, and then you apply the water underneath the car to the battery. You need about 125 to 150 gallons a minute on the battery. Really simple. People say, well, we're going to lift using airbags. Well, what is an airbag? An airbag is nothing but a balloon. So you're going to fill it up with air next to something that's on fire. Probably not a good idea. I've had other people say, well, we're going to use our hydraulic rescue tools because they're so simple. Are you going to destroy a $25,000 set of spreaders for a car that's probably already a total loss? Just ask it. Risk nothing to save nothing. Risk a little to save a little. Risk a lot to save a lot. I less like a ladder because you can replace a ladder for $800-900. It's a simple lever. You can deploy it. You know, the guys out at the end of the, you know, you build your fulcrum. The guys pushing out at the end are not exposed to the toxic smoke. They're at least 10 feet away. Pick it up, shove some crib blocks in, pull your ladder out. You're done. You might lose some wood cribbing. Just my thought. There's the steps for it. Step 1, ensure the vehicle is stabilized horizontally, 3D. Make sure it's not going to roll away. If fire is present, use the hose line, push the fire back so that you can deploy the, you know, get it on one side, raise one side, typically the driver's side, because that's usually where the HV cables are going to be. You want to be prepared to deliver 3,000, 8,000 gallons of water over time. Use a tick. By putting it up on side, it gives you the ability to pan back and forth with the tick. Cool the batteries for at least 30 minutes. So you're using 150 gallons a minute over 30 minutes. That's 4,500 gallons of water. Cool any hot spots. And then you want to monitor it. It works pretty effective. The next method is the blanket method. Several different fire departments have deployed these. I've been getting ready to do a class on their deployment. I had the privilege of playing with one of these in the Tidewater area of Virginia. We played with one, set a couple cars on fire. It worked really well. The technology is out of Sweden, Norway. No, you cannot just use a regular canvas tarp. It does not work that well. It creates an interruption in the chemical chain reaction and smothers the car. Once you deploy the blanket, you leave it on. Pretty interesting how it works. What it does is the the toxic byproducts of combustion actually work to break down the chemical chain reaction of the fire. Pretty cool. So this one, again, you don't use a standard salvage cover. Make sure the vehicle is stabilized. Use hose lines to push the fire back so you can deploy it. Again, approach uphill, upwind. You got to coordinate the application over the vehicle. You got to develop a plan. Apologize for the typo there. You don't throw the blanket like throwing a salvage cover. You drape it up over the car, drag it up over the car. Then you got to make sure that you get it down tight to the ground. And then you monitor it with a tick. You can actually watch the temperature go down once you put the blanket on. It's pretty cool. You don't spray water on the blanket. Allow the blanket, to do its job. And you don't remove the blanket for, at least 30 minutes, maybe an hour or more until the whole car is cool, and you monitor that with a tick. Now, again, you're tying up a roadway while it's, maybe during rush hour or something like that. Cops or law enforcement may not be thrilled with that, but you're also not dumping a bunch of toxic byproducts into the environment. You're actually making it safer. You want to monitor the vehicle. There's some people that once the car is put up on a wrecker, they recover it. And then actually allow them to take the blanket to the salvage yard. So it's recovered at the salvage yard and they leave it there 24, 48 hours. Again, this goes back to your SOPs, your SOGs.
Tom, question about the blankets, and I have some for later, but since you were still talking about the blankets, is a perfect spot. Are the blankets single use or are they reusable?
No, they're multi-use. Some of them say they can be used up to 3 to 5 times.
Okay.
Did I
That
copy
is
you on, and I apologize for to the audience on a sidebar. Reed, did I copy you on the stuff where we got the request about parking garages, deploying them in parking garages?
I believe so.
There are parking garages that are looking to have these blankets in the parking garage because a lot of parking garages are now under municipal mandates to have EV charging stations, like at a mall or something like that. And there's a lot of questions about deploying these in a parking garage.
Can see the definite suitability of them there. And for those of you asking questions about contamination and water runoff, I do have several questions on that, and we will get to that. Tom Lance from Montevallo Fire, Chief at Montevallo Fire, asked a question about what is the cost of that blanket? And I guess I would assume, go ahead and infer this for Lance, manufacturers to speak to about it.
There are different manufacturers of it. The cost depends on the size of the blanket you buy and how much markup your vendor is going to charge you. There's not one size fits all blankets. There's a what's called a PV blanket, which is a passenger vehicle blanket. There is a mid V blanket that's a little bit larger, and there's a CV commercial vehicle blanket. The PV blanket, I've seen prices of $2,300 to $2,800. The commercial vehicle blanket, I've seen prices of $14,000.
It's quite a range. So
yeah, but there's also a nozzle built by Rosenbauer for putting water underneath the car. It's $30,000. Again, you have to go back to your risk assessment to see what you're going to spend money on.
And Lance, it may be one of these things where our cooperative purchasing agreements, like HGAC, if they don't already have something like this on it, it might behoove us to request that they put something like this on it. So it'll be a negotiated price and save people some funding if they're interested in doing that.
I know that the United States Department of Defense has put a RFP out to get a quote on it. So you may be to buy it under government bid. There's different things out there. I know that in the Tidewater area, the blankets we played with were bought by a local car dealership that sold electric vehicles, and they donated 2 of them to the fire department. So I know that you have some vehicle manufacturers down there that are getting ready to buy or build a lot of EVs. You may want to speak to Mercedes or Honda to see if they're willing to do some kind of goodwill. Again, you've got to decide what you want to do. I know the FDNY has deployed a bunch of these. Not saying that everybody has an FDNY budget, but they viewed it as a cost-effective alternative because they can put 20 burning electric bikes underneath one. You know, they look at it more than just for cars. So different things. The third method I like to call the dumpster method. Basically, depending on the design of the dumpster or the container, some of them one end folds down and you basically use a wrecker, the push bar, and a wrecker to push the car into the dumpster, and then you fill the dumpster up with water or the container up with water. You will notice in this picture that there's a light coating of foam applied to the water, which is used for vapor suppression to minimize the off-gassing. Pretty interesting, pretty expensive. The FDNY or the New York City Department of Sanitation has deployed at least 4 of these for use. It's kind of in the prototype stage, but it is out there. These are used all over Europe. The London Fire Brigade has a bunch of them. Paris has a bunch of them. Cities in Germany have them, Sweden. It's pretty common over there. This one particular one here you see is from Bundevere, which is out of Sweden. It's a technology. It's their solution to the problem again, but you've got to look at it. I know that there are certain cities where specialized tow operators are looking at buying these and contracting with a municipality to use them and deploy them on things. So in this case, in this picture, this one belongs to the Swedish Fire Service, but in parts of, United States, there's tow operators that are buying these and going to contract, to deploy them when requested.
Tom, very interesting. You mentioned the tow operators because of the cost that's involved in these and the fact that you can bill insurance companies for hazardous material disposal. One of the major operators in our area in Sumter County, Alabama, Simmons Wrecker has actually looked and they're of course a Mississippi-based company, but a large tow operator has looked at purchasing this because it looks like they can bill somewhere in the neighborhood of $10,000 to $25,000.
Correct.
For the disposal of that vehicle because they have that piece of equipment. So
that's 80 grand. That dumpster right there is 80 grand. 80,000 US dollars.
Yeah, just a couple of vehicles and it pays for itself. So there is some move to see tow operators do that, and probably would not hurt to discuss, especially if you use a private tow operator to help with some of your hazardous material cleanup in your more rural areas, that this would be a good topic of conversation to have with your tow operators.
And again, FDNY is deploying these because you can throw 60 e-bikes in it, or, 200 Makita cordless power tools. And because once the thermal runaway starts in a battery bank or a battery system, you got to assume that everything's bad in it. And it's, it's a piece of technology. And like I said, it's 90,000 euros, $80,000 US, steel container. Like I said, some have the ends that fold down and you shove the car up in. Some they literally have a clam truck that comes along, grabs it while it's on fire, picks it up, sets it down in there, and the fire department just pumps it full of water and puts some surfactant in there to suppress the hydrogen fluoride and phosphoryl fluoride vapors. It is what it is. There's all kinds of different things out there, folks. It's no two places are the same. Again, it's not just fires. If the battery cells are impinged or damaged, that's a problem. If the battery is turned upside down, it doesn't work right because the coolant inside the battery doesn't get to where it needs to be. So these cars on their top pose more of a problem than if they're on their wheels. Again, punctures caused by guardrail bolts, tree limbs, road debris, and yeah, a deer or a possum is a road debris. Even though in West Virginia we have a roadkill law, you can actually eat whatever you kill on the road with your car. We're a lovely state. And again, if the battery's immersed in water, such as being in a ditch or a flood situation, there's what's called cross grounding can occur, energizing any of the metal parts of the battery or of the vehicle. So that's wonderful. Another special consideration you got to think about is EV weights affect crash dynamics. So whenever you're doing EMS and you're looking at mechanism of injury and all this other stuff, and the one that they excite in the National Transportation Safety Board study is a GMC Hummer EV weighs over 9,000 pounds. The normal one weighs around 6,000 pounds for the gasoline version. Ford F-150 is a ton to a ton and a half heavier than the non-electric version. And when you start looking at weight differentials, a 2023 John Deere electric tractor, the one you saw a picture of, is 62,000 pounds. It's 2 times as heavy as its diesel counterpart. So you show up on the thing and you've taken a farm rescue class, and they'll tell you that your 20-ton set of airbags will pick up that farm tractor if it's rolled over on top of Farmer Jones. And all of a sudden, your 20-ton airbag system is totally useless. A Bluebird electric school bus, diesel version is 22,000 pounds. The electric version is 36,000 pounds. Again, GMC Hummer, 9,440 pounds. Go all the way down to a Tesla Model 3. Comparing it to a Toyota Corolla weighs 2,700 pounds because they're about the same, interior space, same vehicle length, width. But however, the Tesla weighs 4,079 pounds, 1,300 pounds more than a Toyota Corolla. I don't know if you saw the incident with the parking garage collapse in New York. Well, now they're saying that the weight of these EVs may be contributing to parking garage damage and parking garage collapse, because a lot of these places, the parking garages are putting the EV charging stations on the roof because of the danger of fire. They don't want to, so they think it's safer, put the charging stations on the roof. It's easier to wire. If there's a fire up there, it doesn't damage the entire structure. Everything vents to the air. But what's the weakest part that's engineered of a parking garage? Anyone want to guess? Because it's not under the weight load of the building. What's the weakest part of the parking garage?
Top part.
The roof. The top part. Well, you put all that extra weight up there. Let's say you got 30 vehicles up there, like the one in New York, and each one weighs a ton more than the other one. You've now got 60,000 pounds weight load on there that it was never designed for. That's bad. Bad. So you got to factor all that in. There's a recent study out of Europe that's just generated all kinds of stuff flying around. The studies are showing these things are in more accidents than regular vehicles because of that weight differential. The braking systems aren't designed, everybody wants to go flying up and down the road, but the braking systems are wearing out earlier. And this is insurance data. This is stuff that's saying these things are more dangerous than a typical passenger vehicle. And the longer these things and the more these things get on the road, the data is starting to show that when these things crash, there's bad things that can happen. You got to remember, whether you're dealing with a fire incident, a motor vehicle crash, or something else, you got to conduct a full scene survey. You got to do a 360 of it. Am I dealing with an EV? Am I dealing with a hybrid? What am I doing? You got to wear full PPE, including using fire gloves, because rescue gloves do not provide arc protection. These things can arc 12 to 14 inches, and I'm going to show you a video here in a little bit of showing you one on a flatbed wrecker, and it's just putting on one heck of a lightning display. Always approach an uphill from an upwind. You got to understand that you got to assess for potential battery cell damage, but do it safely. Any strange or noxious odors or whiffs of smoke are warning signs. If it sounds like Rice Krispies on steroids, like popping, snapping, cracking, arcing, little lightning bolts coming below it, get away from it. Be prepared to cool it. If the battery cell has been immersed in water, danger sign. If you start hearing weird noises coming from the vehicle, like humming or buzzing or anything like that, that's a warning sign. Look for static type discharges, little lightning bolts that come down on the ground. Someone asked earlier, what about patient entrapment? Even if it's immersed in water. How many of you all train on rapid victim patient removal? Have you ever practiced that in your drills? Can someone put something in the chat? How long does it take you to get them out of the car? You ever practice getting a patient out in under 30 seconds? Anything in the chat? It can be done. You got to get them out. You may want to do that out there. You got to be careful. If the patient or responders are exposed to smoke or vapors, you got to treat it as a chemical exposure. You got to implement the appropriate medical calls. HF is like Brill cream. A little dab will kill you. Look at NFPA 473 or work with your local medical command to come up with protocols. You got to stabilize this vehicle. You got to make sure it ain't going nowhere. I'm not a big fan of rescue struts or jacks, because what you're doing is you're putting a big metal pole up against the battery compartment, because we're usually taught to, brace to the floor pan. But if you don't know what you're looking at in the middle of the night, you may be shoving that rescue jack and creating a perfect ground between the battery cell and the ground. That's just bad. In towing and recovery, you got to make sure that they're handled properly. They're towed by a flatbed. Wheel lift wreckers cause problems. You got to be careful. You truly got to be careful. That stranded energy is dangerous. That is the remaining electrical charge in a battery after an incident. And remember, these electric vehicles are designed to go down to 20%. At 20%, they say the battery's dead, but they're not really dead. There is remaining energy in that battery. It's just kind of like when your gas gauge is on empty, you can still go a little bit. Same way with that energy stuff. You got to realize that stranded energy can cause electric shock, either direct or indirect. Can also be the impetus for thermal runaway, and it's enough energy to reignite. Other special situations involve fires in tunnels. Sweden and Norway have burned more electric vehicles than anybody else inside tunnels. They've gone crazy with them. Austria, but they've used that information and that data to apply it to parking garages. And when you get subsurface parking garages, some that are 3 stories down underground, you got to remember these gases are typically heavier than air. They have vapor densities of 1.2, 1.5. So you might get migrations of deadly gases, fill up a parking garage. I don't know how many of you all have trained on dealing with vehicle fires in the basement of a parking garage. You're going to have to look at your SOPs and your training procedures. You notice that these vehicles inside a tunnel are giving off 6 to 7 megawatts, not kilowatts, 6 to 7 megawatts of heat energy. The issue that becomes in Europe that they're looking at with tunnels is those tunnels were not designed, and that concrete was not designed to deal with that amount of heat. So there's dangers of spalling concrete and concrete failure if you didn't have enough to worry about. And then all the toxic gases and smoke are trapped in an area. And it just gets better. Other special situations are larger vehicles, commercial vehicles. That GM hybrid right there, that whole floor pan of that van is a battery. Has about 11,000 cells in it. DHL has 30,000 of these things on the road. Now they have what's called an exposed battery compartment. If you can see underneath that van right there, it has an exposed battery compartment which is designed to help cool the batteries. Interesting design configuration, but there it is. Then we go to school buses. And are you familiar with the black lines on the school bus, what they mean? One above the wheel, there's the floor, then there's the bottom of the seat, then there's the window rail. Notice that one has a black rail at the bottom. That's because there's a reinforced rail there to protect the batteries. And that whole floor pan of that bus is a battery. We won't spend much time on this for purposes of this one. This slide always generates lots of controversy and lots of discussion, but they are out there. Bunches of them out there. But to sum it all up in a nutshell, you got to be prepared to adapt. There can be problems that are compounded with EVs that you wouldn't ever have to deal with again. Again, getting tanker support for a normal vehicle fire. What are you going to do? There's an incident out of Pennsylvania where they had a car carrier where they had 9 of these things on fire on a car carrier. There's an incident out of Elyria, Ohio, where 2 Teslas decided to meet head on in the middle of the road. You know, what starts off as a normal incident all of a sudden becomes compounded. You got to be prepared to establish a water supply. Again, minimum 3,000 to 8,000 gallons for a passenger vehicle. One commercial vehicle fire that I saw, they estimated they put 240,000 gallons of water on the fire to put it out. You're going to have to be monitoring. That's a lot of water. Post incident, what are you going to do with towing and recovery? You got to tow these things on flatbeds. You can't, you can't be playing with them on a regular wheel lift thing, because if the battery's damaged, you're going to pick it up and kink it, and you run the risk of creating a whole new problem. You got to monitor it when you're loading it for signs of arcing. I'm going to show you a video on that here in a minute. You want to make sure that the towing and recovery operator knows that this thing is, bad, and that you're going to, he's going to have to monitor it. He can't take it, drop it off in his yard, drop it in a big mud puddle. You might want to let your dispatch know that it's a electric vehicle involved, and that gets everybody in a response mode where they understand the road's not going to get opened up right away. A new thing that you're going to be dealing with, and there's lots of federal money out there for it, is wireless charging in the middle of the street. So what you're going to do is you're going to find a street somewhere where they're putting 14,000 volts in the ground to charge your car while you're at a stoplight. That can't have any problems, can it? I see everybody in the chat going, oh no, that sounds safe. Well, we got wireless chargers for our phones, wireless chargers for our Apple Watches. We got wireless chargers for our earbuds. And now we've got wireless chargers for our electric vehicles. What could go wrong? How could that go? Yeah, see, Lauren, I like Lauren. It's totally safe. We're from the government. We said it's safe. We're going to do that. Now imagine the other things when the car flips on its top and it happens to be, not that auto accidents ever happen in an intersection. And remember, these batteries don't work well when they're upside down, but this thing flips upside down on top of one of these wireless charging things at an intersection. How could that go wrong? So you're going there to cut it. You think you've de-energized the battery, and at the same time, it's being charged at 14,000 volts. I see nothing wrong with that. Again, you got to consider it with all actions. You got to identify, immobilize, and disable. It only gets better from here. So any questions? And now I'm going to pull up.
Tom, I've got several questions while you're pulling that up.
Okay.
And if I missed a question, I apologize. I'll put it back in the chat and I'll grab it. But if the battery packs are sealed, how are you supposed to get water on the battery itself without penetrating the battery pack?
You don't want to necessarily penetrate the battery pack. What you want to do is you want to get water on the outside of the battery, because that will cool it. There will be a transmission of that cooling power inside the car, inside the battery cell.
Okay. And the water runoff does create an environmental hazard. And one of the things I put in the chat, folks, is that ADEM, the Alabama Department of Environmental Management, is looking at some regulation potentially around this particular area. They have not done anything yet. I know there are federal guidelines and regulations, but it does create an environmental hazard. But I think you said dilution is the solution. If you are using water, copious amounts of water is the best way to take that.
The solution to pollution is dilution. And you got to look at your environmental regulatory authority. There are some states that are much more strict than others. There are some states that, as long as you put the 8,000 gallons of water down, they're good. You have to decide.
Another question that's been posed is, what risk does the vehicle being plugged in cause? What is the safest way to unplug the vehicle if it's plugged in and on fire?
Do it remotely with a pike pole, and get the vehicle away from the charging cord. Because you have that charging cord could arc. If the cord has been burned or had flame impingement on it, you assume that the cord is compromised. So you want to make sure that you treat it just like a down power line. You can move it with a piece of fire hose, move it with a piece of rope, move it with a wooden handled or a fiberglass pike pole, again, using fire gloves, and isolate it.
All right, and following along with that same question, the charging cables, is it possible to cut off the charging station? And one of the things that I've read recently, Tom, and I'm sure you've seen this, is that in some of your pre-plans, you want to treat any service station or area that has a charging station, do it exactly like we do the emergency shut off for gas pumps. Make sure
Right.
you mark those breakers where they are. That's a way to isolate that remotely.
That goes to your code enforcement.
Correct.
Here,
And I think even some of your code enforcement has the quick disconnects, like you would see on your larger voltage appliances and air conditioning systems in your homes.
correct. The slide that you see up there on the screen is we did a test battery, 1/300th of the energy of a typical EV battery. That's what it looks like when it explodes. What you see being discharged out of there. Can you all see my mouse on my screen? Moving around.
Tom, I'm blind and I'm at the back of the room. So if someone's closer. He says it's on the 3rd of June. So
3rd of June, 2022. You will notice down in the lower center, you will see these are actually battery cells coming out. You will notice one that's about 2 feet off the ground that looks like a rocket going up. You'll notice the flame trail coming off of it. All this burning stuff up here in the air, the little white things, that is burning magnesium. Not that burning magnesium things. We actually caught the asphalt on fire here. The place where we were doing the training wasn't very happy with us, but we actually scorched the asphalt. Let me see if I can find the video here.
while you're looking for that, I think I have 4 more questions and we can take them all at the end, or I can keep asking them now. It's completely up to you.
Go ahead, ask. I'm good. I want to help you out.
Has anyone tried high expanding foam to smother the fire like the blankets we discussed?
Okay, first off, you have to understand what foam is. What is foam made of? It's made of air, concentrate, and water. What happens to air when it's superheated? It expands, so the bubbles pop. So foam doesn't really work. There have been some successful applications of foam if you're able to get the F500 foam, and F500 is the only one they've really tested with, inside the battery cell where it fully encapsulates. Is that always possible? If the outer shell of the battery compartment is not compromised, then it's not going to work. So you got to be careful with that.
Is there a way to discharge the battery on scene? Basically that ties to if stranded, the other one, if stranded energy can cause reignition, the runoff can be acidic. And I think I'm gonna ask that question because I have 2 that are together. So is there a way to discharge the battery on scene?
Yes. If you can get like a heavy set of jumper cables, like really good ones, not like the cheap ones, not like a cheap set you buy at AutoZone. You can use a grounding rod, like my favorite's a good old piece of rebar, heavy rebar. And ground the car and go to one of the high voltage cables and make sure you get a good connection, at the junction, and ground the car, dissipate the energy. As you saw, you know, it is, you got to get it in the right place. If you don't get it in the right place and don't know what you're doing and don't practice it and train with it, it's not going to work. You can ground it. If you notice the picture there of the Tesla that was on its side, they actually got into the battery by consulting the ERG and grounded the battery. But you got to know what you're doing. You got to practice it. You got to do what you got to do. I'm going to show you a video now from.
I'll save this last one. So go ahead and show the video, because the last one I think is one that you'll want to expound a little bit on.
This is a situation where they they put the car on a regular wrecker and did a wheel lift on it and kinked the battery. And now you'll notice in the video, you'll see the wrecker driver walking away going like, I'm not going to have a job tomorrow. I have no more wrecker. That's why you don't tow them with a conventional wrecker. Now I'm going to find my other video.
And while you're looking for that, I think this was one of the questions last time that sparked so much conversation, and that is the old handling it by allowing it to burn, by isolating everything around it. If possible, is it better in times just to let it burn?
You have to come to that decision on your own. There are lots of people that do that. I know many fire departments that's their SOP. They'll isolate it, shut everything down, let it burn. If that's what you want to do and you feel comfortable doing that, I don't think anybody's going to beat you up. You have to look at your resources. You have to look at your SOPs, your SOGs, and, you know, are you going to mobilize a tanker task force for, you know, for a car that's already totaled on the roadway?
And one of the people that posed that question, they have a portion of I-10, and I-10 in Alabama is a non-user friendly highway, if you can call it that. So putting a tanker task force in that type of environment would probably be difficult depending on the time of the year and time of day, especially with the isolated amount of hydrants. It brings up an interesting point that one of the things that has been looked at in our area, we do have quite a bit of interstate, but 3 of the overhead bridges that cross the interstate have fire hydrants within a couple of them within 200 feet of the center of the bridge, and a couple of one of them probably around 700 feet to 1,000 feet, but easily possible that you could you know, set up relays off those bridges to keep those tankers filled if necessary. And all of this is going to be a traffic obstruction, but, you know, folks, you kind of have to explain this to your law enforcement folks that this is not something that you can prevent, and keeping traffic at a standstill is probably the best thing. I know that is definitely a Tim's issue, and in the state of Alabama, if it's still on fire, it's still a fire department operation. So, you know, they're just going to have to, I guess, take a seat and cool the jets.
You know, there's even major metro departments that have, you know, adopted that. Again, you've got to decide what you want to do. I can't tell you that there are people that blow up and say, "Oh my God, don't do that."
Tom, you mentioned SOG, SOP. This is definitely a situation that I would encourage departments to have an SOG and not an SOP. Because an SOP is going to limit you, an SOG is going to give you that ability to make a choice based upon the environmental impacts, whether water's available, what crews do you have available, what's traffic like? There's so many things that would play into this. That would, if you lock yourself into an SOP, you're probably gonna lock yourself into something in court.
Yep. And now I'm going to show you the video of what happened, what it looks like whenever they're arcing on a flatbed wrecker. That's a Hyundai electric SUV on a flatbed wrecker. It is arcing against the metal bed of the truck. That entire wrecker is energized. Not a good day. Any other questions?
Tom Ann has a question there in the chat. She says that if the batteries are in the exploding stage, is there a possibility of, not sure, something that even with PPE on, may want to clarify that.
If
I'll
the
give her-
batteries are actually in the fragmentation or the deflagration stage, stay back. Just let it go. You're not going to stop it. The reaction is so uncontrolled, and the fragmentation is creating further damage to the batteries. It's going to be a Humpty Dumpty situation. All the water in the world is all you're going to be doing is putting water on there, and you may not make any difference. Once it gets to the lightning show like that, it's going to burn.
And someone asked a question earlier, and I didn't get it into my document, but is there a possibility of being electrocuted depending on the type of stream that you use on these vehicles?
No, absolutely not. If you're familiar with Ohm's law, we did a lot of stuff, spraying a lot of water, straight streams, and got zero feedback, zero pushback at the nozzle. We actually put ohm meters and everything else and amp meters on the end of a nozzle. Nothing.
Okay. There are some general comments in here about being located to Mobile Bay. The watershed sounds like let it burn sometimes is best depending upon the environmental impact where you're at.
Well, that's
Again-
getting into a whole Coast Guard issue and everything else.
Yep. That was exactly what I was fixing to say. That opens you up to federal regulation.
Oh, but you got to realize we talked about this, Reed, when I was down in Tuscaloosa in November. Mobile Bay, the port at Mobile Bay, is getting tons of batteries from Indonesia, from China, from the African continent, and they're coming in. And like I said, it has at any one time is the third largest repository of these batteries in the entire US. That's a handful. And I kind of researched that before I went to Alabama, and I was just shocked, and where we're talking about a Tesla battery that weighs 1,200 pounds, you're getting shipments in the port of Mobile Bay of 200 tons of lithium batteries, 400 tons. You're getting whole EV, the ship that sank off the Iberian Peninsula was going to dock at the port of Mobile Bay.
And
That
Tom,
means-
a lot of that is coming in containers, and it's not being loaded onto trucks in Mobile. But for those of you that live along the rail corridor coming out of there, coming up 43 towards Selma, and of course, along the CSX line along the coast, a lot of that is staying in containers on the rail cars, and it's not placarded, but Ask Rail will have the designation. If you're not familiar with that application, that's something you definitely want to look up and get access to if you are having any major rail corridor in your coverage area. Ask Rail will give you the manifest of that train. So, and especially with the number of derailments that we've had lately, it's definitely a high value item to make sure you have access to that data.
And the other thing is a lot of times the reason why it's not placarded is because it's labeled as auto parts.
Absolutely.
And auto parts are not a, hazardous material. Our car windshields, hazardous materials. They may be placarded 3481. They may have a lithium ion battery placard on them if it's a responsible shipper. But then again, it may not.
How about questions here in Tuscaloosa? Anybody in the room here in Tuscaloosa have questions? They're all quiet. Screamer Fire Department has a question, Tom, that just popped up on my map, my screen here. If the ground becomes energized due to pools of water in touch with battery pack, what is the procedure for handling this situation?
When you say the ground becomes energized, define the ground. It's a good question, but first off, you don't want to ground to a guardrail because you can energize 200 feet of guardrail.
I think they mean the ground the vehicle is sitting on. If it's
It typically won't energize the ground. It may energize the puddle. The ground is typically once it's arcing to the ground, it's grounding out, so that you don't really run an incident of secondary electric shock. It'll ground a puddle. If the car's into the guardrail, you can energize the guardrail. But a good way to do that is just dissipate the energy. Use that set of jumper cables and go drive a stake in the ground or do something to test what the current is. Do you have an amp meter or a rail beat or an ohm meter to test if there's any kind of current or resistance on that? Because you're either going to have positive energy or resistance energy. So that's, it's different. And I am aware that the rail car fire in Birmingham was not an EV. They were batteries that were labeled as hazardous waste. And they were in drums and packages that, are not, but they weren't packed properly. Moisture was allowed to get into the drums. There was insufficient arc resistance between the batteries and the container drums and the batteries and the construction of the actual transport unit. Yeah. The two separate incidents. Yes, there are ERG designations for ion batteries, but you have to understand there's different ones for lithium iron phosphate, lithium cobalt oxide, lithium manganese phosphate. You have to know the type of battery you're dealing with. And each manufacturer, like for example, Mercedes uses cattle batteries, CATL, which is who makes them, which are typically lithium ferric oxide, which is a lithium iron oxide battery, or a lithium manganese phosphate battery. You have to make sure that you're dealing with the right one. But there are ERG designations for all the different types of ion batteries. I think it's also important to point out there's a difference between a lithium metal battery and a lithium ion battery. I believe the semi incident was in Birmingham. It had drums in it that had waste batteries in it.
Yeah, and I remember it being in Birmingham. I couldn't remember. I thought it was in a commercial area or industrial area. I just couldn't remember where it was, but I saved that article to my EV file here, knowing that it was something local that could come up.
The incidents in Birmingham have
Stephen.
sparked a great deal of discussion on a federal level. Birmingham Fire Department did a great job. The fire departments down there did a great job with what they had to work with. It's just a really bad situation, and there's a lot of discussion and with the shipper over their interpretation of how things had to be packaged versus how they actually packaged it. And a lot of this is subject to interpretation. Do we have to label it if it's, disposable waste batteries? You don't have to label a container full of used oil filters, which are waste auto products. A lot of discussions. Been on a couple of phone calls about that.
You see the question there. Would these apply to shipments of less than 1,000 pounds of cargo?
Depends. on what is your regulatory environment. For example, the West Virginia Public Service Commission, after WVU started this, now requires if you drive through the state of West Virginia, anything over 100 pounds of waste batteries has to be labeled. If a recycling center by code under now the West Virginia Fire Code has applied. Now they used to not apply to salvage yards and junkyards. Now, if you're storing more than 500 pounds of waste battery material, you must report that just like a tier 2 form to the local fire department.
Yeah, you know, here in Tuscaloosa County this weekend is a tech disposal event. And there's no telling how many devices will be turned in at local at locations all across the county that carry lithium-ion batteries. No telling how much of that will be collected. So definitely something. What was that? I'm sorry, Tom.
To Christopher McCain's question, I think from my experience, it's been lithium cobalt oxide.
All right. Any other questions in the chat or in any of the rooms that people are watching want to unmute and ask a question? Remember Tom's message, there's no such thing as a dumb question. So now's a good chance to ask that. That's a great question. Michael Bailey with Brookwood VFD asked if anyone would like to buy an electric vehicle after learning of this. I'm assuming Michael has one for sale. If the price is right.
I will tell you, I did this class at NASA at the Neil Armstrong Space Center in Sandusky, Ohio. And, they're rocket scientists, no joke, rocket scientists. They probably had like 24 of them out there. So NASA, just so you know, they started the EV stuff. The lunar rover was an EV. There wasn't an Exxon station on the moon. And so they were joking about it. We did the class. And when we took a break, because we actually did the operations level class, when we went out for lunch, when we came back, there were 4 for sale signs on the Teslas in the parking lot. And the guy was like, look, dude, he said, your science, as you're aware, Reed, we had, the guys from the School of Engineering down there looked at what we were putting in our training programs, and they said our science was spot on. And that NASA rocket sciences says, you want a Tesla, I'll sell it cheap. You can have it, take over payments and get rid of it. And he actually joked, he said, don't know if I want to drive it home.
Yeah, it's amazing how people change their opinion of things once they learn the hazards. And maybe that answers your question earlier about suppression of statistics. And
I want to point out something. I don't mean to interrupt you, Reed, but there is not a single National Transportation Safety Board or National Highway Transportation Safety Administration rule or regulation written for any vehicle, internal combustion or EV or hybrid, that is designed to protect first responders. Everything is designed to protect the consumer. The crash testing is designed to how does the compartment hold up for the passenger to prevent injury. There's nothing about what danger does that vehicle pose to the first responders who come to do the extrication. There is not a single safety regulation out there written for EVs or hybrids or any internal combustion engine about the safety of first responders. None.
And to answer Ann's question, Ann, if there's anything that comes up after the fact, feel free to email me your direct question. I will pass those on to Tom if I can't find you an answer for those. And Appleton VFD down in Escambia County, Alabama, says that you spoke earlier about driving a ground rod to dissipate batteries. How deep would it need to be driven into the ground? They have a concern over utilities being buried in the median and other places. So
again, that's where you've got to look at. I usually, whenever I do that, I tell them to ground to where the guardrail is, because they put guardrail posts in the ground. It's usually what's called composite soil, so it's easy to drive into, because you got to realize guardrails are designed to give. They're not designed to be rigid. So you want to drive it 12 to 18 inches in the ground. That's where I like to go, is that, it's usually like crush and run or something else that's put over there around the guardrails. And that's about how deep the guardrail posts are in. So you want to get it down into that type of, that soil. And you want to make sure that your other end is connected either to the battery cables the high voltage cables, or to the metal parts of the frame, like the lower control arms, the A-arm, a tie rod, something metal on the car.
All right, and Ryan Maynor asked a question, is there a big difference in fires in full electric vehicles versus a hybrid that also has liquid fuel sources, especially when fighting that fire?
Yes. Hybrid vehicles, like I said, are, twice as likely to burn, and you have the additional gas. They typically don't have large fuel cells. Fuel cells are 10.6 gallons or smaller. On a full electric vehicle, the thing you're dealing with is temperatures. On a full electric vehicle, on the batteries, and they typically have magnesium engine blocks for lightweight. So then you got the magnesium that's burning and everything else. And when you spray water on it, yes, it will fragment, and you'll have the violent reaction. But the key thing is the temperatures. Most electric vehicles burn at 1700 to 2100, 2200 degrees. Some as high as 2,800 degrees. There's documented incidents of the temperatures inside the battery cell or battery compartment being high as 2,900 degrees. So that's really high. And then you get what's called a steam pop, where the steam actually is, when it applies, it's coming back so great. Even in an open atmosphere, it's a violent release of steam. And that creates a danger for firefighter visibility, creates a danger for firefighter mobility. You just got to pay attention to it. Most hybrid vehicles, the battery cells don't discharge so much energy. So they'll top out at between 1500, 1700 degrees in terms of fire.
Okay. Any other questions? I don't see any other questions in the chat. If I've missed something, please bump it now. If not, Tom, you have any other comments, any closing comments while we're checking on any other questions?
No, I just, thank you all for your time.